Okay, good evening. Welcome to Math for Kids number
51.
number 51.
51.
Yeah. Today we're going to talk about continued fractions. We've done a movie about continued fractions before. I don't actually remember
Projects.
when it was, but that's fine. This is like week of fractions.
Yeah,
So
it is going to be a week of fractions.
continued fractions are a super fun kind of fraction, and they kind of have a sad story, actually.
Why sad?
Why sad?
Yeah.
Because
They go on forever?
No, that's not sad. It's really great when things go on forever. The sad thing about continued fractions is no one studies them anymore. It just stopped. People stopped studying them. I don't know why, actually, because they're really, really neat. So let me show you what a continued fraction is, and then we'll do it. So like it's something like this: 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. That's a continued fraction.
And you can keep going on and on and on.
Yeah. We'll do one at the end of this video that just goes on and on and on, and we'll try to figure out what it is. And then in tomorrow's video, it'll be some suspense. You'll have to wonder about it overnight, like what it is. Okay? So this is a continued fraction. And let's see if we can figure out what this is. This is some other fraction that we would normally write some way, but let's see if we can figure out what it is. You want to give it a shot? The first thing you have to do is add 3 plus 1/4. And can you tell me what 3 plus 1/4 is?
Well, so just do the concept in our earlier video.
Okay.
We multiply that. And this, I'm only doing this bottom part.
Yeah, that's all we're looking at right now. 3 plus 1/4.
12 fourths plus 1 fourth, 13 fourths.
Okay, so 3 plus 1/4. I guess the best thing for me to do is just erase 3. So this used to be 3 plus 1/4, but instead we're going to write this as 13 fourths. Okay?
Yep.
All right. So now we have 1 plus 1 over 2 plus 1 over 13 fourths. And so now the next thing we have to figure out is what is 1 over 13 fourths? 1 divided by 13 fourths.
4/13.
How do you know that?
Because when you have this 1 over thing, you just flip it.
Flip it. Okay? So when you are dividing by a fraction, you can flip the fraction. And it's the same as multiplying. Or 1 over a fraction is the same thing as that fraction flipped. So 1 divided by 13 fourths is the same as
4/13.
4/13. Okay, and now, ooh, my goodness, we have to do 2 plus 4/13. Ooh, ouch.
So I have to do this 2 over 1.
Okay.
Equals 26 over 13 plus 4 over 13 makes 30 over 13.
Okay, good job. Okay, so back up just a little bit. That's okay. All right, good job. So 2 plus 4/13 is the same as 30/13. 30 over 13. So now we have that on the bottom. Oh no, what are we going to do now?
Now it's that 1 over, it's 13/30.
Okay, so it's 1 plus 13/30.
Well, 1 we can rewrite it as to erase the 1.
What would we write it as? So let's see if we can
13
do it.
over 13.
13 over 13. How's that going to help us?
Because now it's 30 over 30.
Oh, 30 over 30.
Because you get the same denominator.
Okay, so this is the same as 30 over 30 plus 13/30.
So this equals 43/30.
43/30. That's pretty neat. So this was 1 plus 1 over 2 plus 1 over 3 plus 1/4. That's 43/30.
Wow.
Wow, that's pretty neat, right? So I don't know what the easiest way to think about this is. Do you?
No.
What do you think is an easier thing to understand? 43/30 or 1 plus 1 over 2 plus 1 over 3 plus 1 over 4?
I think it's probably this one.
Yeah,
Simpler version.
yeah,
43's prime.
you're probably right. 43's prime, are you sure?
I think so.
I think it is too, but I'm not sure. It's always hard to tell Sometimes numbers look like they're prime and they're really not.
Why did people stop studying continued fractions?
Why did people stop studying continued fractions?
Yeah. It just did?
Yeah, well, I think what happened is they used to be part of the things that people studied in high school. And then over time, people decided to start studying different things and they just stopped studying them.
They shouldn't have. They're
No,
really
they shouldn't have. They're
interesting.
really, really neat. They're really neat. Okay, so we just learned how to go from a continued fraction to a number. Why don't we go the other way?
From a number to a continued fraction.
From a number the way we normally write it, or a fraction the way we normally write it, to the other way. Okay. So let's look at. Oh, I don't know. Here, make something up. Give me a numerator. Give me a denominator. Just make the numerator bigger than the denominator. So pick a numerator.
How about 12 fifths?
Okay, awesome. I have no idea what this is going to be. 12 fifths. Okay. So now I remember from my high school math teacher who taught me about continued fractions. Here's how you do this. I don't know if he made this up or not, but you ready?
Yeah.
Okay. The procedure is 1, split, 2, flip, and 3, rat. So it's split, flip, and rat. Okay, that's what you have to do.
He had to make this up.
I don't know. I think I just remember this. Split, flip, and rat. You ready? You ready to do split, flip, and rat?
Yeah.
Okay, so first we have to split. 12 fifths is the same as 10 fifths plus 2 fifths. Okay?
Yeah.
Now I tried to take out as many 5s as I could, so why did I write it as 10 fifths?
Because that's a lot of 5s. And
How many? What is 10 fifths? How would we normally write 10 fifths?
1/2. No. 10 fifths is
10 fifths is?
Is 2.
2, right. 10 fifths is 2. So this is the same as 2 plus 2 fifths. So that's how you split it. You got to take the integer out. Okay? Now, and you're left with a fraction that's bigger than 0 but less than 1. Is 2 fifths bigger than 0?
Yeah.
Is 2 fifths less than 1?
Yeah.
Yeah, okay. So that's the splitting part. Now, can you guess what flip means? We're going to write this as 2 plus 1 over what?
1 over.
2 fifths equals 1 over 5 halves. Remember that?
Yeah.
Okay, so we're going the other way. So split, flip, rat. And I guess rat in this case really means split again. So we're just going to do the same procedure. So we're going to turn the 5 halves.
Split.
5 halves is what? How many 2's are in 5?
2 2's.
Right, so it's the same as 4 over 2 plus 1/2. Okay? So 5 halves is the same as 4 over 2 plus 1/2.
You went 2 over 2.
Oh, geez, thanks. 4 over 2 plus 1/2, right?
Yeah.
Okay, so why did I write it as 4 over 2? What do we normally write this as?
It's 4 halves. We normally write 4 halves as 2.
2, right. Oh, actually, yeah, look at this. You picked a really interesting... Look at that. 12 fifths is the same as 2 plus 1 over 2 plus 1/2.
Wow.
Look at that. Wow, that's really funny that's how that came up.
Awesome.
Okay, that's 12 fifths. So split, flip, and rat. You know why did we stop when we had this last 1/2?
Because you can't get smaller.
That's what we wanted. We wanted 1 over something. Okay? So 12 fifths is 2 plus 1 over 2 plus 1 over 2.
Wow.
How about that? So those are continued fractions, and they're really, really neat. And they're used for solving lots of really crazy equations. And we'll get into that a little bit more tomorrow. But the thing we're going to look at tomorrow in continued fractions is the simplest continued fraction that you can possibly ever think of. And it's the continued fraction that has all 1s. 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 over, all the way down to infinity. Okay?
Yeah, it keeps going down.
We're going to look at that one tomorrow.
How about a continued fraction for pi?
A continued fraction for pi? Huh.
P-I.
Tell you what, that might be a little bit too hard for us to talk about. I don't think you learn about continued fractions for pi until maybe 3rd grade.
I'm almost there.
So I'll show you one. I'll show you a continued fraction for pi. Or actually, I think there's a neat continued fraction for 4 over pi, if I remember right. So I'll show you, instead of showing you a continued fraction for pi, I'll show you a continued fraction for 4 over pi.
Cool.
How's that sound?
Nice.
All right, good job today, sweetie.